Okay, so I'll just do it for n equals k and k plus 1. So n equals k, that means that 1 on 2 factorial plus 2 on 3 factorial. We're assuming true, that this is true. Dot plus k on k plus 1 factorial equals 1 minus 1 on k plus 1 factorial. Okay, so you have to prove true for n equals k plus 1, and that's what you've got there. So that there is your sk, and this here is your tk plus 1. So replace the sk with sk. Now, I think what you've done there, so that should be a 1. So what you got to do is this here, this is sk, like sk plus 1 equals sk plus tk plus 1. Now the sum to k terms equals 1 minus 1 over k plus 1 factorial. That's that there. Tk plus 1 is k plus 1 on k plus 2 factorial. So you've got to try and make this look the same as this here, because that's the sum to k plus 1. So when you're doing that, I find that it's easier, because this minus is a little bit painful, is to put this one first. So go k plus 2 factorial, 1 over k plus 1 factorial, just because the minus can be a little bit trickier. Now when you're looking at that, you also have to realise that k plus 2 is the bigger one. So k plus 2 is k plus 2 times k plus 1 factorial. Okay, so because it's k plus 2, k plus 1, k minus 1, etc. So when you look at this here, that there, all you have to do is times that by k plus 2, and you'll have k plus 2 factorial. So times the top by k plus 2. So if you look at that now, all you need to do now is to simplify that top line. So if we look at that line there, that is 1 minus 1 plus k plus 1 on k plus 2 factorial minus k plus 2 on k plus 2 factorial. Okay, so that's 1 plus k plus 1 minus k plus 2, and it's all over k plus 2 factorial, which is 1 plus k plus 1 minus k minus 2 over k plus 1 factorial. So the k's, over k plus 2 factorial, so that's the denominator. The k's will cancel out, and you get 1 plus minus 1 on k plus 2 factorial. And if you look at that, that's 1 minus 1 over k plus 2 factorial, because that's your, and if you look at that, that's your prize, so that equals the right-hand side.